All right, everyone. Welcome to this little session entitled Manufacturing Slack. I'm sorry for the confusion. Google made it awfully difficult for me to connect my YouTube account with my Google Plus account, and I got all messed up. Plus, I wanted to do this as a Hangout on Air and not the original Hangout, and so the original invitation with Google Plus was all messed up. So I really hope that you guys find this, and in the very worst case, when I do this again in the future, I'll have a little bit better idea what I'm up against. In the meantime, we'll just do our best. All right. So, and of course, technology is becoming just a little bit more tricky. So let's find now. Now I have 3 or 4 of these all starting at once. This is fantastic. There we go. All right. So let's start. And I just hope that people will, in the very worst case, you folks will see this on YouTube later, and we'll kind of go from there. So the reason that I wanted to call this manufacturing Slack has to do with the fact that I think for a lot of people, it's likely the case that you already understand that Slack, that people need Slack. And I'm trying to tell those of you who are watching somewhere else to come over. All right. Yes, so the goal today really is to look at not necessarily the reasons why you need Slack. I'm going to assume that for the most part, you folks know why you need it. I'm going to talk more about how to get it. But perhaps before I do that, it might be a good idea for me to first look at what do I mean by Slack. Now, the standard, for me, the gold standard in understanding Slack is the book Slack, unsurprisingly, by, I believe, by Tom DeMarco. I know I was just reading it, so you'd think that I would have this off the top of my head, but let me just go quickly to the Amazon page for it. It is, in fact, Tom DeMarco. The book is called Slack, Getting Past Burnout, Busy Work, and the Myth of Total Efficiency. And in this book, Tom looks at from essentially all angles, why Slack is important and how it can help you. And Slack really boils down to excess capacity. Now, I realize replacing one word with 2 words doesn't really mean that much. So Slack is the intentional, or at least the way I think of it, is intentionally setting aside some of your capacity to produce work in order to do other things. And those other things can include reserving, or those other things can include relaxing, having fun, and intentionally finding ways to improve your capacity to produce. So that's essentially it. Slack is, for me, all about managing the 2 parts of our work life. One of them is time spent actually producing work, and the other is time spent improving our production capacity. And the reason for that comes from an observation I've made and a phenomenon that other people have described that I believe is true, and that is that when we don't take care of production, when we don't pay attention to our production capacity, when we don't pay attention to our capacity to produce work, then our capacity to produce work slowly declines over time. And I'll have to say that it probably looks a little bit like an inverse logarithmic, I don't know if it's inverse or mirror logarithmic curve, but what happens is that our capacity to produce work slows down slowly until it picks up speed and falls off a cliff. You've certainly experienced this in code bases if you've worked on a code base for a long time, and it slowly becomes more difficult to deal with until all of a sudden it seems like during a single week, it goes from bad to worse to impossible. And the idea there is that because we're not paying attention to our, because we're not paying attention to our capacity to produce, that that drops off rapidly. And that's the phenomenon that I've seen over and over again. And it's not just in coding work, but it's in all other kinds of work. When we're not working to increase our capacity to, when we're not working to improve the way we work, which is a way of increasing our capacity to do future work, our capacity doesn't just stay steady. It actually declines over time. And that decline is the problem. And that's what I want to talk about today. Is I want to talk about what can we do to find time to improve. And the number one problem that I think everyone has is that they want to improve, but they don't have the time to do it. They can't find the time to do it. They don't have the energy to do it. They can't find the money to do it. Somebody else is putting pressure on them not to do it, to focus on producing and producing. And that one effect that a lot of people don't understand is that, as I said, if you focus all your energy on producing and don't take any time to pay attention to your capacity to produce, then what happens over time is your capacity to produce decreases, which means that the amount that you produce decreases over time. You get slower and slower, less effective. You work under more pressure, work with lower quality, and that's all a big feedback loop in and itself. So that's really the basic problem. And so I'm going to take it as an assumption for today that Slack is a good thing and that you want more of it and you want to find out how to get more of it. But that's really what you're trying to do. If you're working with people who don't understand the value of Slack, who think that Slack is wasting time, is sandbagging, is withholding maximum production power from your customers, then you definitely need to give them a copy of DeMarco's book Slack and have them read it so that they can see all the ways that trying to work at total efficiency aren't helping them. Now I'd like to turn our attention, I suppose, to how do we find Slack? Because this is really the big problem. Even if we agree that Slack is important, then the question becomes, what about the fact that I'm already way too busy? In fact, the only reason that you're interested in this at all, likely, has to do with the fact that you've got a backlog of work to do, you're already behind schedule, you're already low energy, you're already high pressure. What do you do? And that's really where I want to go now. Is I want to share some of the basic techniques, the basic principles that I use to help find Slack. Because I'll tell you that this is one of those things that I'll tell you that I think will probably make you feel good and bad at the same time. And that is that you already have the Slack you need to start improving. The problem is you can't see it, or you can't utilize it. And I use the word utilize very specifically because the Slack is there, it's latent, it's sitting, it's waiting, but nobody's using it, nobody's looking for it. And that's kind of what I want to talk about today. And then I want to take a bunch of your questions. So my goal is to describe to you the techniques that I use in general terms, and then I hope there will be enough of you asking questions that will get into the nitty-gritty details, and you can tell me all the reasons that this isn't going to work, and I'll see if I can help you. Now, I want to point out that the material involved here, the ideas not only came from a few books that I've read, and obviously stuff that I've done with clients, but a lot of this crystallized when I prepared a session with Naresh Jain for Agile India, I think 2010, where we took his experience with coaching teams with just-in-time and theory of constraints and my ideas about Slack and put them together. And so I'd really like to thank Naresh for helping me crystallize a lot of these ideas and for sharing with me what he knew about the topic, because the two are very tightly bound together. The basic idea is we can use the theory of constraints, and specifically bottleneck theory, to help figure out what we should be working on And then we can use the agile practices from Lean, Scrum, XP, Kanban, whatever, as ways to improve the situation. For me, the big problem, of course, is that we have too much to do. We feel like we don't have enough time to get things done. We feel like we're already well behind. We're already under lots of pressure. And we feel like we can't take the time to try to improve anything. That the only way that we're actually going to improve anything is when, say, Derek over there in the corner decides he's had enough of writing crappy code and he's going to spend his spare time on evenings and weekends. Of course, he doesn't really have a lot of spare time, but he's going to spend spare time on evenings and weekends reading about design, trying out things like test-driven development, trying to refactor some hard legacy code, and that's how he's going to get a leg up. That's one way to manufacture slack, is to look outside your work time and create work time from your personal time. And of course, this is probably the most time-honored way of finding time to improve, is dipping into your probably relatively small reserve of so-called free time to do your improvement. This is based on the idea, the wrong idea, I think, that my employer is not going to invest time in me trying to improve, so if I want to improve, I'm going to have to do it on my own time. And I understand that a lot of employers think this way, and a lot of employees, even if they work for more enlightened liberal employers, probably feel pressure when they're at work to produce real work, so-called real work, and then use their personal time to improve. But this, for me, is really not a sustainable model at all. I think that not only do we need to spend work time trying to improve, but we have time at work that we can use to improve. And what I want to do right now is describe how to tap into that. So, very, very quick introduction to theory of constraints. Theory of constraints, whether you agree with it or not, you can do some reading. The Eli Goldratt book, The Goal, is kind of the gold standard introduction to the theory of constraints. But even if you just read the Wikipedia page on the topic, you'll get enough to get started. The basic idea in theory of constraints is that instead of when we try to make every resource in a system 100% busy, then the time it takes for a piece of work to get all the way through the system necessarily goes up. This is something, and by the way, the time that it takes for a piece of work to go through the system is something we call throughput. So the throughput of the system is how much completed stuff can we take through our system. Now, if we view a software delivery team as a system, then we can think of the units of work coming out of that system as running tested features that are deployed and in use. This is sort of the general idea behind Agile software development, that we want to produce as many units of running, tested, deployed features in use and delivering value to customers as soon as we can. And that's based on the idea from the theory of constraints that we want to improve the throughput of the system. And the throughput of the system has to do with reducing the time it takes to go from when somebody requests a feature to they can start using it and using that to deliver value for themselves. So we can measure throughput through a software delivery team as the number of running tested features in deployment, in use, helping people deliver value for themselves. And this is our throughput. Now, theory of constraints is based on two basic ideas. One, that we want to improve throughput while also reducing two other things, which are operating expenses and investment. I'm not going to get into the details of what those things mean. As I said, you should go read the Wikipedia page on theory of constraints, go find a copy of the book The Goal, and you can read about those in much more detail. The only thing I care about is that we want to improve throughput without also increasing costs somewhere else in the system. That's good enough for now. Now, the other aspect of theory of constraints is the idea of bottlenecks or constraints. I'm going to use the term bottleneck just because I like it and I'm used to it. The basic idea is that every system has a bottleneck. The bottleneck is the part of the system that constrains the overall throughput of the system. So the bottleneck is the part of the system where work goes through the slowest, And one of the general ideas behind theory of constraints is that the rate at which work goes through the bottleneck constrains the rate at which work goes through the entire system. That's what bottleneck means. And it's a very simple proof to know that every system has to have a bottleneck, because if not, it would have infinite throughput. So the bottleneck could be anywhere in the system. It could be at the very beginning, somewhere in the middle, somewhere near the end. But the idea is that because the system doesn't have infinite throughput, there must be a part of the system where the throughput at that part of the system is the same as the throughput for the whole system. And that constraint, that we call that the bottleneck. That's the slowest part of the system. And every system has different constraints. There might be multiple constraints that have very similar throughput with each other. The constraint can move. When you try to improve the throughput through the bottleneck of the system, then the bottleneck might move somewhere else. But the idea is that the bottleneck determines the throughput of the system. Now, there's a few nice things that happen as a result of this idea. One is, it means that there are other parts of the system where the throughput through that little part of the system is higher than the throughput of the bottleneck, which means that it's higher than the throughput of the whole system. Throughput with each other. That means that at some constraint can move when you try to improve the throughput through the. That means that sorry, somebody came in and didn't mute their microphone. Please, folks, if you join, please make sure to mute your microphone on the way in. The nice thing about there being a bottleneck is that means that by definition, other parts of the system have excess capacity, because there's the throughput through those parts of the system could be higher than the bottleneck. Well, if the bottleneck determines the throughput of the whole, and if some other part of the system, not the bottleneck, has a potential higher throughput than the bottleneck, that means that part of the system, by definition, has excess capacity. If there's excess capacity, then that means there's the potential for slack, because that's what slack is. Slack is excess capacity in some part of the system that we can use to invest in the system. And what are we going to invest in? We're going to invest in increasing the production capacity of the system. So, for example, in a software team, if you have a tester who's sitting there not doing anything because they've already tested everything that we've built so far, and they're waiting for the programmers on the team to build more parts of the system for them to test, then they might be sitting there idle. And that idle period, it represents excess capacity. Now, what could that person do? Well, that tester could just sit there and wait for there to be software to test. Wait for a new version of an old feature to be delivered, wait for an early version of a new feature to be delivered. Right now, they're in a position where they can be maximally responsive by just sitting and waiting for software to be delivered so that they can jump on it and test it. And that's one of the ways to use excess capacity. One of the simplest ways to use excess capacity is simply to remain idle so that you can be maximally responsive when a piece of work comes up. And this is part of what DeMarco talks about in his book Slack, that when everybody is busy, then nobody is responsive. And that's why work then piles up in inboxes in front of the next person, because that next person's completely busy. They can't jump on work when it becomes available, which means that their responsiveness goes down, and that's what slows the work down through the system. At every step, if you think about it from the work's point of view, when I go from person to person, if everyone is busy when I arrive in their inbox, then I'm going to sit and wait for a while. If they were less busy, then they'd be able to jump on me, the piece of work, when they receive me. And that responsiveness allows me, the piece of work, to flow through the system more quickly. So, in the case of our tester, one of the ways that we can ask the tester to behave is simply to wait until there's something to test, and then they can jump on that and start testing it right away. And that decreases the time that bit of work waits, and that increases the flow and allows that bit of work to get through the system more quickly. And if every person who needs to work on that piece of work jumps on it as soon as they're available, that should reduce wait time, and that should increase throughput through the system more quickly. So, in the case of our test, now, we don't necessarily want all excess capacity to be used just for waiting for work. That's the good news is that by definition, because there's a bottleneck, that means that at some other parts in the system we have excess capacity. We have people waiting around for things to happen. Now, in the typical business model, we would encourage those people to look busy, to do whether they need to do things or not. What I'd like to do is use that excess capacity for improvement. And the problem, of course, is that work doesn't arrive at people's desks in a predictable manner. People don't necessarily know when they're idle because they're expected to look busy, and so things like Parkinson's law kick in, and they either slow down so that they look busy, or they find other things to do so that they look busy. But what I encourage you to do is to use those bits of slack as an opportunity to reinvest in your own skills. And so one of the simplest things you can do is simply look at when you have idle time and use that idle time to improve your skill on your own. This is something that you can do without needing permission from your manager, without needing permission from any of the people around you, because by definition, unless you're the bottleneck, you have slack time. And even if that slack time is 15 minutes here, 30 minutes there, you can do a bit of reading, you can do a bit of experimenting, you can pop open a little hobby project and work on it for 30 minutes. And I encourage you to feel absolutely no guilt in doing this, because what you're doing is using your existing slack time to improve your skill, not only for yourself, but also so that you can produce more quicker for your employer, for your manager, for the other people on your team. I think this is a perfectly reasonable way to do things. Now, of course, you do still want a way to make sure that you're not letting work sit and wait for you. But if you're not the bottleneck, then you could use some of that time, this idle time, to improve your own skill. Now, of course, the cruel irony is that the ones of you out there who have already done this in the past, the ones of you who have spent your personal time and some of your time at work improving your skills, improving your habits, and getting better at what you do, have likely turned yourself into the bottleneck. And you know you're the bottleneck because there's always a lineup of people at your office door waiting to ask you questions. There's always a huge backlog of emails of people asking you questions, of people saying that they're stuck because they need your help. Or whenever there's a serious problem and there's a fire to fight, you're the one involved in fighting that fire. That means that you're the bottleneck. That's a very clear sign, in fact, that you're the bottleneck. So what should you do? I remember when I worked at IBM, it took me only a couple of years to reach the point where I became nominally a technical lead, and as a technical lead, people expected me not only to do my own job building features and writing code, but also to answer other people's questions, to give them advice, and to find better ways to do things. And all these things together made me the bottleneck. Once I'm become the bottleneck, then now I'm back in the situation where in order to improve my skills and even just to get to knock down the backlog of work I have to do, I have to steal time from my personal time bank account, if you will, in order to do work. I have to either work more hours, I have to come in early when nobody else is there so I can get work done, or I have to stay late when nobody else is there in order to get work done, or I have to do work on evenings and weekends just in order to get the backlog down. And this is where I now need the rest of the team to help me out in order to be able to get out of the way as the bottleneck. Because the trap that you get into when you become the bottleneck is you're the person who seems to be fastest at doing things, which means you're the one they ask to do it. But once you are overburdened with work, it doesn't matter how fast you are because there's no more work that you could possibly be doing. You're probably doing work at the fastest rate possible, which means now the team can't go any faster because you can't go any faster. And the fact that you are the fastest at doing these next 5 pieces of work doesn't matter if you can only work on one thing at a time. So one of the ideas that you can help, one of the ways that the team can use the slack that it has is to recognize that if I'm not the bottleneck, or sorry, if I am the bottleneck, then how fast I am at doing any particular piece of work is totally irrelevant. As soon as I have too much work to do, then how fast I go doesn't determine how fast that work gets done. That's an extremely important thing, not only for you to recognize, but for you to encourage the people around you to understand. That if you're the bottleneck and you can only get 2 things done a day and you have a backlog of 10 things to do, it doesn't matter that you're the fastest at doing the other 8 things. You're still only going to get 2 things done today. Which means that even if, you know, Rachel in the corner takes 3 times as long to do those 8 things as you do, and she can only get 1 or part of 1 thing done a day, Rachel should start working on at least one of those things, because otherwise that piece of work is going to wait for you. So one of the ways that you can use the slack that your team has is to recognize that if other people on the team are not the bottleneck, then it's okay for them to do work even if it takes them 2, 3, 4, 5 times as long to do it as you. Because if you're the bottleneck, you already have too much to do. Either the 10th piece of work in your backlog waits 8 days for you to start working on it, or Rachel starts working on it now and she gets it done in 4 days. Well, even if Rachel takes 8 days to do it, she's going to get it done in the same amount of time that it would take for you to do it, because there were 9 other pieces of work in front of that 10th one to get done. So one of the other simple ways that you can improve capacity is simply to stop clinging to the idea that because Derek is the fastest at doing a piece of work, then Derek is the one who should do it. That's definitely not always the case. As soon as Derek is overloaded, then it doesn't matter that Rachel takes 4 times as long to do it. She should start helping out and doing the work. Now let's assume for the moment that we've dealt with those. What's the next thing that we need to do? Well, now we've reached the point where we've recognized that Derek's the bottleneck. We recognize that other people on the team can do some of the work that we would otherwise want Derek to do, and we're doing a better job of using the team's capacity. Now the problem is that the team needs to learn to go faster. And there are a couple of ways that the team can go faster. One is to reduce waste, and the other is to improve their skill. The problem now is that the team is probably pretty close to using most of its capacity. So where is the opportunity to improve skill and to eliminate waste? If we don't know where our waste is, we can't eliminate it. And if we are busy producing work, then we're not going to take the time to improve our capacity. And that takes me back to one of the first things that I said when I started today. If we don't try to actively improve our production capacity, then over time our production capacity will slowly decline, and the rate of decline will increase over time. That decline will accelerate until all of a sudden it looks like we can't get anything done anymore. And that can be because the code base deteriorates to the point where adding features costs too much. It could be at the point where everybody is so tired that they're making more mistakes and aren't doing good work anymore. There's a bunch of reasons for this. So now, how do we as a team manufacture more slack? Because we've used all the slack that was lying around waiting for us. Maybe everybody's now 80% busy, 90% busy. They're pretty close to not being able to find any more free slack lying around. What can they do? And this is where one of the most powerful techniques I've ever used can help us out. And that's something called value stream mapping. A lot of you out there probably already know about value stream mapping. I want to, first of all, encourage you to read books like Implementing Lean Software Development or From Concept to Cash by Mary and Tom Poppendieck, who describe value stream mapping quite well. And again, you can just find the Wikipedia page for it, read a few articles. The basic idea is this. The value stream is the set of activities, or I should say the stream, the sequence of activities that go into getting something done. And the simplest example I can think of is fixing a defect. So somebody spots a mistake in our system. A tester finds it, a customer finds it, a programmer finds it, I don't care. But at some point, somebody finds a mistake in our system. And they say, oh, we made a mistake. And at that point, the clock is on. As soon as somebody finds that mistake, the clock starts. Now the question is, what are all the activities that go into fixing that mistake? Now, broadly speaking, we have to identify the mistake. We have to describe the mistake somehow so that other people can verify that that mistake really exists in the code base. Then we need to find the source of the mistake in the code. We need to fix the mistake in the code. We need to verify that we've fixed the mistake correctly, that we haven't broken anything else in the process, we then need to deploy that fix so that the end user will see the difference. When they use the system, the mistake is now gone. Broadly speaking, those are the steps involved. Now, in your company, there are a bunch of little micro steps that are involved, like somebody enters a ticket into a bug tracking system or sends an email to somebody, and that email sits and waits in somebody's inbox for an average of 4 hours until they read it, and then it takes 2 days for the programmer to recreate the environment in which the mistake was found so that they can verify that the mistake exists, and then they have to read through the code to hunt down the source. These are all the micro activities that go into fixing that mistake. And so the stream of activities includes essentially 3 kinds of activities. One are the kinds of activities that add value, such as fixing the mistake, describing the mistake, reading through the code to look for the source of the mistake. These are all steps that add value to the system, that contribute to our throughput. There are waiting situations. There are times when the work sits and waits for the next person to do work. The mistake might sit in a bug tracking system and wait for somebody to read the bug. It might sit in somebody's email inbox waiting for somebody to read about it. A request to set up a test environment, which requires the operations group to do some work, that request might sit in somebody's inbox. It might sit and wait while the one operations person who can handle the problem is on lunch, and they'll be back in 45 minutes. These are all situations where work is waiting. And then, of course, there are non-value added activities, such as entering the bug description in a bug database so that a programmer can read that bug description later, instead of having the person who found the bug go directly to the person who can fix it and describe the problem. You could imagine that in the latter case, I should say the former case, adds activities that don't add value to the system. They are a kind of bureaucracy or a kind of waste that we add for other reasons. Maybe it's because the person who found the bug is in Europe and the person who's going to fix the bug is in Canada. And so then I can't just walk down the hall to find that person. Or because they're working in a completely different time zone, I can't just call them up and talk to them directly. Or maybe we have some governance system in place that requires us to track that bug in some kind of bug tracking system. So these are all non-value added activities that nevertheless are necessary. So we have the 3 kinds of activities: value added, non-value added, and waiting. And so value stream mapping consists of first deciding what the beginning and the end of our value stream is. So we decide that the beginning of our value stream is the moment that somebody finds the mistake, and the end of the value stream is the moment where the first paying customer receives and starts using the fixed system, where the bug is no longer there. Now, once we've decided the beginning and the end of the system, the next thing we do is draw a diagram with all the activities in sequence that go from the beginning to the end. So, Joe finds a bug. That's the beginning of the system. Joe logs into the bug tracking system and spends 15 minutes describing the bug in enough detail so that other people will understand what that bug really means, and attaches some screenshots or attaches a video that shows the bug happening. And what we want to do is write each of those activities out in sequence and draw arrows from activity to activity. And sometimes we have loops and sometimes we have branches, but we do our best to draw in as much detail as we can all the activities that go from the beginning to the end. And then for each activity, we look at how long it takes for each of those activities to be performed. And it might be useful to describe who performs that activity. And this is where I find it really helpful when mapping a value stream to think about a specific incident. That way we tend to think about more details rather than just thinking in general, well, what do we usually do when we fix a bug? It's very easy to forget activities that only happen part of the time or bad luck activities. We want to include those. And so I always recommend that teams, when they do this, they actually pick a specific incident in recent memory or a particularly interesting incident and draw that one from beginning to end. Now, in addition to the activities where people are doing things, of course, there's waiting time. So, for example, in the transition from Joe describes the bug and puts it in his bug database to Michelle reads the bug description and starts creating the test environment on our machine, there might have been some time where the bug report sat there waiting for Michelle to read it. Maybe there was an email notification. Maybe it waited until there was a meeting the next day at which the manager of the team said, hey, folks, we have this new bug. Or maybe Joe went over to Michelle's desk and said, hey, I just put this bug in the bug database. It's really important. Can you take a look at it now? But there's some amount of waiting time. It might be a few minutes. It might be a few days. And so right in the amount of time that it takes for that piece of work for something to wait to go from one activity to the next. And so now what we have at this point is a long stream of activities. Each activity describes some step that goes from the beginning to the end. Each activity is marked with who's doing it and how long it takes to do it. And between activities where the work has to wait for the next person to get started, or had to wait since we're talking about a specific incident, we also write down how long it took for that work to wait. And by the way, since everybody asks me at some point, yes, if the work sat in somebody's inbox while they went home and went to sleep, then that's 16 hours of waiting time from 5 o'clock in the afternoon when they left the office till 9 o'clock the next morning when they started working on it again. That 16 hours counts. Now, we can mark each activity as either adding value or not adding value or waiting. And this is where we get into a lot of arguments about whether an activity is adding value or not adding value. I like to use a really simple rule of thumb. If you and I are going to argue about whether an activity adds value or doesn't, let's pretend it adds value for now. In other words, let's mark every dubious activity as though it adds value. Don't worry about it. We'll come back to that later. So once we've done that, we've marked all the activities according to who does it, how long it took them to do it, how long work waited, and whether that work added value or didn't add value. Now what we have in our value stream is a concrete picture of all the work that doesn't add any value, all the things that require work to wait. And those things represent latent slack in the system. That's where we can look for slack look for time that we can recover and use that time to invest in improvement. And at the highest level, it's really that simple. Our job now is to look at our value stream, to look at places where work waits, to look at the areas where we do non-value added work, and see if we can eliminate those. Now, the lean folks would call that eliminating waste. I have seen that, and it makes intuitive sense to me, that the areas where work waits almost always point to potential bottlenecks. And especially if you mark on your value stream the places where work is waiting for a specific person. If work is waiting for a specific person, then that's a clear sign that that person, or that, I shouldn't say a clear sign, that's a sign that that person might be a bottleneck. And especially if you look at your value stream for fixing a defect, and at 3 separate points in the value stream, the work waits for the same person 3 different times, that's a clear sign that that person's becoming an individual bottleneck. That's a clear sign that that person needs to spend time training other people to help her do her work. Because especially if different bits of different parts of the work are waiting for the same person, the risk there is that if that person becomes unavailable, then work grinds to a halt. The recent book about continuous delivery, The Phoenix Project, and I wish I could remember the author's names right now, but I can't, describes this situation absolutely beautifully. And so I strongly recommend looking for the book, The Phoenix Project, a fable about implementing continuous delivery, to see how insidious these bottlenecks can be. And so now we can use the very simple idea from the theory of constraints to recover some of that wasted waiting time and some of that wasted non-value added time. The easiest thing to do is to try to look for waiting time and eliminate it. Look for ways for people to be more able to work on that stuff. And that could be that a bottleneck person, so if Derek's the bottleneck, Derek spends 2 weeks pairing with somebody else on his work so that that other person can help him out. And even if that other person takes 5 times as long to do the work as Derek does, it doesn't matter, because Derek can only do 10 kilograms of work a day. And if somebody else can do 2 kilograms of work a day, then at least now the team is getting 12 kilograms of that work done instead of 10. And the longer that person practices doing that work, the more work they'll be able to do day after day after day. And eventually they'll get to the point where they can do, say, 6 or 7 kilograms of that work a day. Even if they never get as fast as Derek, the team overall has more capacity to do work. And if Derek's the bottleneck and the throughput through his part of the system goes from 10 to 17, that means the throughput of the entire team will go from 10 to 17. And I don't even care what the 10 and the 17 mean. The idea there, remember, is that if we increase capacity at the bottleneck, we have a chance of increasing the capacity of the system. But if we increase capacity outside of the bottleneck, that doesn't actually help. It would be better for people for the people who aren't the bottleneck to sit idle than it would be for them to do busy work that don't need to be done. What they could really do, again, is spend their time learning how to do the work that is at the bottleneck, whether that means learning the raw skills to be generally as good at their job as Derek is, or whether that means working directly with Derek, seeing what he does, and then doing that kind of work better. Now, in retrospectives, this is a great opportunity for us to do this work. We can take time in retrospectives and look at incidents of work that were particularly difficult, particularly slow, particularly painful, map the value stream, and look for waiting time and for non-value added activities, figure out who the bottlenecks are, and then those are the people who need to pair. Or figure out what the bottleneck activities were, and those are the skills that we need to improve. So when we find the bottleneck people, those are the people who need to pair, who need to describe what they do to other people so that we can get work away from them. And if we identify bottleneck kinds of work, where there's only 1 or 2 people on the team who know how to do that kind of work, that represents a skill that other people on the team need to learn. So we can use this value stream mapping to identify the things that we're not very good at, and then use either general purpose books, like maybe we're not good at a certain kind of testing, maybe we're not good at a certain kind of programming, maybe we don't have enough people who know a certain API, who know a certain third-party product. And we can get training in those areas and improve our skill. The other option is to say, well, there's some work that we need to do that we know will help us improve our capacity, whether that's improving our overall quality, or improving our overall understanding of the domain, or improving our overall ability to communicate with our customer. And those become some of the things that we can improve by using tools from the Agile Toolbox. So we could learn test-driven development because we have a really high defect rate, and defects are becoming a bottleneck. And so if programmers do more testing, then our defect rate will go down. We'll spend less time working on defects and more time building features. Or if our design is in really bad shape, and we know that improving the design will make it easier for us will make it easier for features to flow through the system in the future, then we can practice test-driven development in order to improve our design, and that'll lower the cost of adding features. Or if we constantly fight back and forth with our stakeholders, where we think we understand what we should build, we build it, and then they tell us that's not what we wanted, then that means that we need to communicate not just more often with our customers, but we need to do a better job of understanding what they're trying to tell us. So we can learn tricks from behavior-driven development, from feature injection, from specification by example, in order to do a better job of getting the picture in our head to match the picture in their head. And that increases the likelihood that what we build is what they wanted. These are all different ways that we can improve our capacity to deliver good work. One of the simplest ways that we can improve our capacity is to deliver less bad work. Deliver less work that has defects. Deliver less work that makes it harder to add features later. Deliver less work that isn't quite what the customer wanted. Deliver less work that isn't what the market is willing to pay for. One of the most important conclusions from the book The Goal is the idea that, when Rachel screws up, because Rachel's not the bottleneck, when Rachel screws up, she loses a little bit of her capacity. She wastes a little bit of the time, but that's not the end of the world. When Derek screws up, because Derek's the bottleneck, when Derek screws up, he's wasting capacity of the entire system. Whereas when Rachel screws up, because she's not the bottleneck, she wastes a little bit of her capacity, but she can still get all the important work done that she needs to get done, because she has excess capacity. But when Derek screws up, it's a problem. Now, it's not even that Derek screws up. When Derek works on code that is in really bad shape, he's not only wasting his own time, he's wasting the entire team's time. His throughput limits the throughput of the system. So when Derek has to wade through crappy legacy code, that hurts the whole team. When Derek has to work with buggy code, then that wastes the whole team's throughput. When Derek tries to build a feature that isn't quite what the customer wanted, because Jill over there didn't have a good understanding of what the feature should be, or because the manager told Derek that Derek couldn't talk to the customer directly and Derek has to guess what the customer wants, every minute that Derek wastes doing the wrong thing, producing the wrong work, producing bad work, is wasting capacity of the entire team, not just his capacity. That makes it even more important that we figure out what he's doing and make it easier for the rest of the team to do it well. That's all more important why Derek's skill needs to improve. Even if Derek's the best on the team, he needs to improve his skill, because if he's the bottleneck and we're not going to divert his work to other people, then he has to get better at what he does. So let me summarize. Slack is excess capacity. We can improve by taking some amount of our excess capacity and using it to improve what we're doing, either by learning new techniques or by having other people on the team learn what the best people on the team do, or by having other people on the team learn more of the domain, more of the technology, become better communicators with the customer. By definition, because every system has a bottleneck, that means that there are some parts of the system that have excess capacity. And if those people don't spend that excess capacity improving their skills or learning how to do important work, then Parkinson's law virtually guarantees that they're going to make themselves look busy. They'll also make themselves look busy because the company wants them to look busy. We have this culture of people wanting to look busy. Instead of them spending time looking busy, they need to spend time either improving their skills in general or looking at what the bottlenecks on the team do and helping them out. When we identify the people who are the bottlenecks, either we need to spend some time helping them improve their skill, or we need to spend some time getting people to learn what they do so that more people can do it. And in fact, I'll remove or there and replace it with and. We need to do both. We can figure out in detail what activities are creating problems by mapping the value stream and looking for places where work waits and looking for places where people are doing non-value added tasks. And we can especially look for places where the bottlenecks on the team are doing wasteful work. Either they're working on buggy stuff or they're working on stuff that's not going to be approved by the stakeholders, because when a bottlenecked person does the wrong work or does it poorly or makes mistakes, it's not just burning their capacity, it's burning the capacity of the whole team. We can then use the ideas from Lean, Scrum, XP, Kanban, FDD, DSDM to help us find techniques that we can use to improve our skills in general. The value stream and looking for bottlenecks helps us figure out where the problems are that we should fix. And the books that describe techniques in Lean, Scrum, XP, Kanban, FDD, DSDM, Crystal, those are the techniques that become the tools in our toolbox to try to make things better. And that's how I like to help teams coach themselves. I encourage teams to deeply understand where their bottlenecks are, what the worst problems are that they need to solve, and then look in the Agile toolbox for techniques and ideas that are going to help them solve those problems. And those are the kinds of training that I encourage them to focus on. And that's one of the primary reasons why this investment in improvement is not just a matter of getting some guru to come in for 3 days and do some training and then leave. This is an ongoing activity. What you can learn up front is the technique for figuring out where your problems are, and the basic understanding of how Slack works and why it's important to generate Slack and how you can actually find Slack. It's like it's sitting in the couch cushions waiting for you to find it. What takes time over time is this repeated cycle of finding the bottlenecks, trying to improve capacity at the bottlenecks, either by making other people able to do that work, or by increasing everyone's ability to do that work, or by increasing everyone's effectiveness at that work. And then, over time, the bottleneck will shift to some other part of the system. So you can map a value stream, you can map the same value stream every 2 months for a year. And that value stream will look different because as you improve at certain parts of that value stream, as you get more efficient and more effective through those parts of the system, the bottleneck will move. And so it's important to map the same value streams over and over and over again so that you can see the system changing over time. And that changes over time the areas where you focus your improvement. And I think that's everything that I want to say. So I use the ideas from theory of constraints to help figure out which problems to solve, and then I use techniques from the Agile toolbox to figure out how to solve those problems. And I just keep repeating and repeating and repeating until the bottleneck is completely out of our part of the system and it's somebody else's part of the system. And when that happens, we have a couple of choices. We can either go on vacation, we can quit our job, take our knowledge, and go make more money somewhere else, or we can teach them what we've learned and help them become better at what they do. And really, I think that's a question of personal style. All right, I did a lot more talking than I expected. I'm going to hang around and answer as many questions as I can for as long as I can. And I'm not sure how many people have tried to ask questions here, so we'll just hope for the best. And so I'm going to take this actually, anyone who's in the Hangout who wants to, in the group chat, say that they have a question, can just say, I have a question, so that we can ask them, we can get them to unmute themselves, or I can unmute them and get them to ask. So do we have any questions? I'm going to go take a look in my various places to see where things are. So I see Yves Hanul has done some tweeting just to describe what it is that a few things that I've said. And well, nobody seems to be asking any questions, but I can't tell if that's because they don't. We have a comment from John Kern that just says, "I love the topic of Slack." Good stuff. Thanks very much, John. I appreciate the support. I'm going to go take a look at the YouTube page and see whether anybody's tried to ask a question over there. No. Looking to see whether anybody's asked a question in any of the other... Well, I was kind of worried this was going to happen, and part of the reason why I expected this to happen was because of the confusion about the Google Hangout link, and I apologize for that. When you create a Hangout in Google+, by default, it's just a regular Hangout instead of a Hangout on Air, and I wanted this to be a Hangout on Air, so I know better for next time. Let me just take a quick look at the Google Plus page and see whether, by chance, there are some questions here that I can answer. I can also look here at the Wufoo forum. No, nobody's asking any questions there. So just a few things. I'm going to look here and see if there are any questions here. Let me just work my way backwards here. Interesting. There don't seem to be very many questions. Let's see. Oh, here's John. Yes, that's correct, John. There was no slide deck. I don't have one, although I can point you to a presentation. In fact, let me make a note to do that. I'll add in the comments a link to a presentation that Naresh Jain gave on the coaching with just-in-time and theory of constraints, which is what he used. So John says, currently our league developer is embroiled in some nasty member league patching. I was bummed because some other stuff isn't getting done, and now I know why. This is exactly a perfect example of the trouble. And to me, this is something that when I read the goal the first 2 or 3 times, it didn't really stick with me, and now it's absolutely hammered into my brain that when the bottlenecked person on the team spends 20 minutes doing work that doesn't add value, where he's fixing a mistake that somebody else made, he's fixing his own mistake, he's doing work that shouldn't need to be done in the first place. It's not just that he has wasted 20 minutes, he has wasted 20 minutes for the entire team, and you're never going to get that 20 minutes back. It's extremely important when your team is not producing quickly enough, and of course your team is never producing quickly enough. It's extremely important that the people who are the bottlenecks, the people who have are hoarding knowledge, whether they're doing it intentionally or not, the people who are the one person who knows how to do it, when they spend 20 minutes doing something that shouldn't be done, where they're fixing a problem, or they're arguing with somebody, or they're sitting in a meeting and not saying anything and not contributing, they're not just wasting their own 20 minutes, they're wasting the entire team's 20 minutes. You can pretend that every time the bottleneck on the team waste time doing work, pretend everybody else in the team has stopped for the time it takes for that person to get that wasteful work done, because that's really what's happening. And this is, to me, the reason why, not only why it's so important to figure out who the bottlenecks are on the team, but it's also important to help everyone on the team understand that it's okay for Rachel, who goes at 20% the speed that Derek does, that it's okay that Rachel does some of the work that Derek can't do. Because even though it takes Rachel 5 days to do what Derek can do in 1 day, Derek can still only do 1 day's worth of work in 1 day. So if Derek chews through a backlog of 10 days of work, then at 10 days at Derek's speed, then it'll take 10 days for Derek to get through that bit of work. But if you add Rachel and Derek together can get through that backlog in 8 days. And maybe that doesn't sound like a huge improvement, but that means that there's work that gets done 2 days sooner. And so don't underestimate the cost of a bottlenecked person doing wasteful work. If you learn nothing else, learn that. Right, so John's comments, he says, I encouraged him, this bottleneck person, to delegate some of the work to a developer who couldn't do it as fast as he. But I said, at least it'll get done sooner than if I wait for you to get around to do it. Absolutely. And this is exactly the situation that was the sort of the centerpiece of the intrigue of the book, The Phoenix Project, was one of the characters in the book who was so much the bottleneck that it ended up being profitable for the group to institute a rule that bottleneck person, I think his name was Bill, I can't remember, that Bill doesn't touch the keyboard at all. That in fact, in order to maximize the time for learning, for the rest of the team to get up to speed with what he's doing, so that other people could do that bottlenecked work along with Bill, that Bill wasn't allowed to do any of the work himself, that he needed somebody to pair with him, and that person would do all the actual typing. It drives anybody nuts, makes anybody absolutely scared to death to think that this would actually improve the team's overall capacity. But think of it this way. If the goal of the team is to make work flow through the system, if the 6th item in the backlog is going to sit and wait for 3 days no matter what happens, then that item is going to sit and wait for 3 days whether Bill does the work or whether Rachel helps Bill do the work. And if Rachel has excess capacity, then Rachel's availability isn't going to make that 6th piece of work get done any sooner. So there's no reason for Bill and Rachel not to do that work together. And at the end of that task, Rachel knows more than she did before she started. Rachel is more capable of doing that 6th piece of work, and that increases the likelihood that Rachel can do that 6th piece of work and get it done a half day sooner or a day sooner than it was before. And if you keep doing this over time, this is what makes pair work so important. This is one of the reasons I think that pair programming is a useful tool in the toolbox. It has very little to do with making people happy and I can concentrate, blah, blah, blah. All that's true. But the most practical reason to pair, for me, comes from the fact that other people on the team have excess capacity. So it doesn't cost you anything for them to pair with a bottlenecked person on a task that needs to get done. In fact, look at it this way. It's maybe more important for the bottlenecked person to pair because it'll reduce the likelihood of making a mistake. And remember that whenever the bottleneck makes a mistake, it doesn't only cost the bottleneck, it costs the whole team. So Martin Hinia says, I've seen this happen a few times at senior management up to the CTO level, where that person is a former technical phenom. I feel that there's significant cost of turnover for frustrated team members who see this not only as a blocker, but a barrier for personal growth. One of the things that I recognized when I became a bottleneck when I was working at IBM was that I no longer had the time to learn anything. I was forced to produce at 100% capacity because there was literally a lineup of people outside my office door asking me questions. There was literally a backlog of emails waiting for my attention. And not all those emails were, Joe, do this. Some of those emails were, Joe, help me do this, because I was the only one who knew how to do it, or because everybody had this idea in their head that it would take them 12 hours to do it or 18 hours to do it, but it would only take me 3. And this is the insidious nature of bottlenecked people, of having skill concentrated in a small number of people. This is why in Agile we talk about generalizing specialists. It's not because we think there's not because there's some philosophical reason why programmers should learn how to test and testers should learn how to program. I don't care about any of that stuff. It really boils down to this. If I'm the only one who knows how to do it, then eventually that work is going to be stuck in my inbox. And if that work isn't stuck in my inbox, then something else important is going to get stuck in my inbox. And as soon as work is stuck in my inbox, that lowers the capacity and the throughput of the team overall. That blocks the team's ability to produce more work. And it doesn't matter how many more people we add, and it doesn't matter how much better they get at their job. As long as I'm the only one who knows how to do that bit of work, the rate at which I go is the rate at which the team goes. All the more important why other people need to know what I know. Whether it means that I need to teach them the practices and habits that I use that make me more effective in general, or that I need to teach them the specific domain expertise that I have, the specific technology expertise that I have. And if I get stuck and I'm not allowed to teach the people around me, and I have the long line of people out the door, and I have the long line of emails waiting for me, and if I have stakeholders and managers who are angry because I can't work faster, then absolutely I'm going to get frustrated. I'm going to stop learning. I'm going to stop growing. I'm going to stop feeling like a contributing member of the team. I'm going to feel more and more used. I'm going to feel more and more exploited. I'm going to feel less and less fulfilled. And my quit clock gets closer to 12. If you've never heard of the quit clock before, it's like the doomsday clock, right? The doomsday clock says 11:59, and that means that the world is 1 minute away from nuclear holocaust. So, as the superpowers, the Cold War, as the superpowers got closer and closer to lobbing nukes at each other, the doomsday clock got closer to 12. I use the same analogy and call it the quit clock. And so you walk around saying, well, how do you feel today? Oh, I'm at 11:55, or I'm at 11:30, or I'm at 11:59 and 23 seconds. If I'm at 11:59 and 23 seconds, that means that my security badge is in my hand and I'm about ready to leave. The more I am forced to be the bottleneck, the more I'm forced to churn out work that I don't need to be the one to do, the more that I'm forced, for example, to do stuff that I used to do because I'm the only one who knows how to do it, the less opportunity I have to learn and to grow, the closer my quit clock gets to 12, and when you lose me, you're in serious trouble. And so that for me, justifies the ideas both of using pair programming to increase the capacity of the system to do work that would normally be at the bottleneck, and also as a way to make the bottlenecked person to reserve some of their capacity to do interesting work so that they have a chance to learn and grow, and so that will keep them. This is one of the points that DeMarco hits very hard in his book Slack, that the people who are bottlenecks need to reserve some of their capacity to learn and grow and have personal development, otherwise they'll quit, and that turnover will screw you. He refers to that as human capital, and most teams, most of the time, strongly underestimate how much they've invested in human capital. All right, I'm going to take a look to see whether there are any other questions, any other comments. I haven't seen any so far. And once again, I apologize for maybe not being able to take your questions as easily as I could. This is a learning process. Maybe I'll try another session where all I do is answer questions. John says, maybe I should jump on those bottleneck situations and help get over the issue. I like the idea of demanding pairing and sharing so they're more capable programmers. I'm trying to break the culture here of specialists that know where the dragons lie and to share the wealth. And John's point, I love what John says, that maybe it's jump on those bottleneck situations. If you're the only person in your team who recognizes the cost, the true cost of bottlenecks wasting time, bottlenecks doing the wrong thing, bottlenecks doing things that shouldn't be done at all, then it might be your job to forcibly, and I don't usually like that term, but maybe stealthily, maybe surreptitiously find ways to improve the capacity at the bottleneck. Whether that means learning some of that work yourself and sharing it with other people, or protecting your bottleneck and another person, giving them a chance to, sort of saying, shh, you guys go off in the corner and pair for half a day, and I'll make sure that this manager who doesn't like pairing stays out of the room. Whatever it takes to get the team to start sharing that knowledge with the rest of the team. The goal in sharing knowledge isn't because it's a good thing to do. The goal in sharing knowledge is to improve the capacity of the rest of the team to produce work. Now, one of the difficulties, of course, is that the people who have excess capacity are doing busy work. They're doing non-value-added work. They're probably not all doing value-added work. If everybody on your team is doing value-added work, then you need to jump to finding new techniques that are going to help the whole team increase their capacity. And that's where you go into a retrospective, you map the value stream, you look for weighting and for non-value added work, and you look for tools in the Agile toolbox to change the way you work. And the only way I know to make that actually happen is to reserve some portion of your capacity, 5%, 10%, to do improvement activities. But if you have excess capacity and you know that there are people on the team who are doing busy work, and that you could get away with them sitting idle and it doesn't hurt the team, then instead of having them sit idle, those are the people who are absolutely ripe for working with your bottlenecked people to learn what they know, either to learn the specific domain knowledge, to learn the specific technology, or to learn basic effectiveness habits. What I would recommend against is sending them off to do training to learn to do TDD or to learn to do something else until they've started to learn some of the specific bottleneck work, the work that's sitting in front of the bottleneck. I really think you gain a lot more by having those people learn to do the things that are sitting in front of the bottleneck person. And once those bits of work are no longer stuck behind the bottleneck person, and more people on the team can do them, then it's a good time to look at what you're doing, to look for non-value added work, to look for weighting, to figure out which new techniques to try, and then that tells you what training you need. And it might turn out that, yeah, you have a defect problem, but your bigger bottleneck is that you're not really clear about what the customer wants, in which case you need training in BDD or specification by example. My product sashimi training might be much more important to you than the TDD training. Whereas your programmers might have this idea, this intuitive feeling that we have lots of bugs, therefore we need TDD so that we do our own testing, and then once we fix the bug problem, the big problem will go away. Until you actually map the value stream, you run the risk of solving the wrong problem. And if bugs really aren't your bottleneck, if the bottleneck is something else, then getting better at TDD or getting better at testing or hiring more skilled testers or hiring better programmers with better habits will not improve the team at all. It will only increase your cost without increasing your throughput. And that's one of the other things. So not only do you need to look at the bottleneck person and get them to stop wasting time, but you also need to make sure that you don't invest in training and learning stuff that isn't your deepest problem, that isn't part of the bottleneck. Now, it's very important, as I say that, to remember that this isn't a reason to stop
improving because you don't know where to improve. If you're not sure where to improve, if you can't tell where your bottlenecks are, then you should spend some of your time just improving what you can and some of your time hunting down the bottleneck. And when you see where the bottlenecks are, that gives you a better idea what you need to improve. But even before you go there, it's still a good idea. It will probably provide more value for you to take some of the people who have excess capacity, stop them doing busy work, and get them to jump on the work that's sitting in front of the bottleneck person. And you probably, if you have a single bottleneck person on your team, you almost certainly know who that is. All right, I'd like to get close to wrapping up now. If there are any other questions or comments, I'd like to try to take them now. I think what I'll end up doing is following this up sometime soon with a pure question and answer session, which of course is what I intended to do today, but it didn't work out that way. Stephen Baker asks whether this is going to be a regular thing. I haven't decided yet whether this is going to be a regular thing. I don't like to commit early, but I will at least try to do this again and make this a pure question and answer session. So people can go watch the talk on YouTube, and then if they have questions, they can ask them, and I'll try to take those questions and answer them later. So I'll give you another 20 or 30 seconds to try to ask some more questions. I'll try to answer them now, and if not, then we'll wrap up for today. Martin Hinney thanks me and says he'll point at least 3 people to the YouTube video. I appreciate that. Anyone out there listening, I hope that you will share the YouTube video with your friends and neighbors, with your family and coworkers. John Kern has said he would do the same. Thanks very much. I think that means that we're done for today, so I would like to leave you with a few references. Certainly the gold standard for learning about all the evils of work that make you or that tell you why Slack is important. Tom DeMarco's book Slack: Getting Past Burnout, Getting Past Burnout, Busy Work, and The Myth of Total Efficiency. I strongly recommend starting with that as the book that you read first. If you have read it, read it again. Some of the other references that you'll find useful: to learn more about the theory of constraints, read Eli Goldrad's book The Goal. If you don't like business novels, then start with the Wikipedia entry on theory of constraints and go. I strongly recommend it. It's definitely a good book. For those of you who don't mind business novels or who even like business novels, then The Goal is, I think, a reasonably well-written one. You can also check out, I'll tell you now, and I'll find the link and put the link on the YouTube video later. Naresh Jain has a presentation that he calls Coaching Teams with Just-in-Time and Theory of Constraints. That gives you an example of how to use value stream mapping and bottleneck theory to figure out, of all the 27 things that a team could do to improve, which one should we do first. And I want to leave you with the final thought that before you run out and spend tens of thousands of dollars on training, before you run out and start a book reading circle that will get a bunch of people attending the first one and 3 people attending the second one and 1 person attending the third one, I strongly recommend that you look around at your team. Look for the person who's very obviously the bottleneck, and but encourage the people who have some excess capacity. Find ways to help those people work with the bottleneck to learn what the bottleneck knows. Look at the work that's sitting in the bottleneck's inbox and encourage people to learn how to do those kinds of work, how to build those kinds of habits. And that is the first step towards finding the slack that you need to do some real improvement. Because if you imagine that over the next 3 months, the team is able to get 10% or 20% more work done because non-bottlenecked people are starting to do the work that was piling up in front of the bottleneck, then you can reserve a little bit of that capacity, whether it's 5%, 10%, and spend that time in your retrospectives or in other working sessions, mapping your value streams, looking for waste, looking for non-value added activities, looking for waiting time, and using that to tell you which of the agile techniques to try. This has been Manufacturing Slack. Thanks very much for your time and attention. If you'd like to find out more about me and my work, and if you'd like to work with me, then go to jbrains.ca or agiletutor.com, and you can read what I have to say on the topic. If you'd like to delve into how to make this work for your team, then contact me at help.jbrains.ca, and we'll figure out how to get things going. Thanks very much for your time and attention, everyone. I hope you enjoyed this, and if you didn't enjoy it this time, then I hope you'll enjoy it next time. Thanks very much, and have a good day.